For number 1, you define the slope. If you subtract these, you get 5 over 0, which is an undefined slope. Number 2, if you put -4 in for all your x's and simplify, you would get 29. And number 3 is looking for the range of these ordered pairs. So least to greatest, this would be -2, 0, 1, 3. Questions on any of those 3? So this is just looking for the range, the y value. So if you look for all of your y values, you put them least to greatest without any repeats. Say that again. What about it? So you're putting -4 in for all of your x's. You put it in for this one and this one. This one you would square, get 16. You multiply these two, you get a positive number, and then add these 3. Okay, and then on the back, number 4, this was a vertical line at -3. So if you remember your Poivox, vertical lines are x equals, it's at -3, so this would be x equals -3. And then the last one was an inequality that you had to graph. So start your y-intercept and slope off the same at -2. Then go up 4 to the left 1 as many times as possible, down 4 to the right 1 as many times as possible. This would be a solid line because of the line underneath. And then this would be shaded above, so if you're not sure which one is above, look at your y-intercept, draw an arrow up, and that region would be your solution area. Questions on those 2? Did we have just math or Khan Academy questions that we wanted to go over? We had a question about, got stuck on something. If you haven't already, make sure you take out the last set of notes that we're doing. There are extras in the crate if you need them. If you need a reminder as to what they look like, the first page had a bunch of graphs on it, or had one graph on it, a bunch of lines. Yeah, and the crate. And the unit 8 and the steel crate. I didn't bring it around this time. I feel like we started on the second page. I'm not 100% on that. It's been a minute since we did it. Anyone that had these notes already, you know the last problem that we stopped at. What was the last thing? We're going to look at this part at the bottom of the second page. I think there are a few more extra copies if you don't need it. There weren't any in there. You will need your calculator if you haven't already got that. Refresh your memory. Last time we were talking about this, we were looking at different transformations, what happens when we put these different things in the calculator. So for this one, and we mentioned something about this, how we did this one, this f of x equals the absolute value of negative x, and when we did it, nothing really changed. This is going to talk about why that really is. So here, they're telling us if we have a a reflection over the y-axis, in order to really see it, you have to move it left or right first. So here, we have a transformation where we're moving the graph to the 2 units to the right. So with this one, we know that with this one, because the negative is outside, it would flip upside down, reflect over the x-axis. They already told us this inside part is moving 2 units to the right. So we can fill out that first part. This would be flip upside down and move or translate 2 units to the right. And then that would be what changed. The actual rule for that would be your reflect over x-axis and translate 2 units to the right. This is great at the end. So I'm going to show you what happens if I put this in. Because we could look at it without graphing it and say, well, there's a negative on the inside, so that would be a reflection over the y-axis, and it should be moving right too. But when I put that in my calculator, I'm thinking it doesn't look like that. Thank you. Okay, so I'm going to put our parent function back in here. So that would be alpha window to get our absolute value, and then your variable. And then we have negative x minus 2. I'm going to put both of these in here and graph them. So we have our original. We have this one, but when we put that second one in, it really looks like it was moved to the left too, and not what we said happened. But with the transformations that we put in, what really happened is it did move to the right too, but then it flipped it over the y-axis. So it looks like it moved left too. So So we could say what it actually is supposed to be, and then we're going to change it a little bit because there are different ways this could be written. So this would be flip over y-axis. Move right here. Or reflect over the y-axis. Translate to the right two. But if we didn't have this negative, or the way it's graphed, it looks like it did this. Let's see. And I'm just going to put that in and graph it and see what happens. You don't need to do this. You can if you want to. So it's kind of hard to see, but this was the original one, and then the x plus 2 is graphed over top of that. So really, those two things are the same. So if you just saw that graph, you wouldn't really know if it was flipped over the y-axis, yes, and moved right 2, or did it just move left 2. Both are technically right. So if you wrote one way and someone else wrote the other, it wouldn't be counted as wrong. Another way you could look at this is, because there's a negative here, I could like factor out this negative. Which would change the signs of everything. And if I put this in, and I graph it, that same thing happens. So which one is it? You're probably thinking all of them, any of them, it doesn't matter. They all end up graphing to the same thing. So you could say it's this, or it's this, or it's this. It doesn't matter. Right? The main thing you need to know is that if you have a negative on the inside, that's going to be a reflection over the y-axis. But if you were to see it, it doesn't really do what you think it does. Yeah. Questions on that before we move on to the next page?
Hey, how do you know we're reflecting on the y-axis from this?
If it has the negative on the inside, right in front of the x.
Oh, okay.
Go to the very last page. This is going to be like a summary of a lot of this stuff. There are a few things you need to know with this, so I'll be drawing things, labeling things, going back and talking about things we've already talked about. Somewhere on your paper, write these two equations. One of these should look somewhat familiar from when we were doing quadratics. And I talked about the vertex form. This is that vertex form. Your absolute values have something similar. You can call it vertex form, call it standard form. This will help us determine our transformation. Right, so we're going to talk about each of these, what they look like on a graph. I'm just going to use the quadratic. You could use the absolute value too. And what these do. So vertical we know is up and down. Your vertical affects your y values. And usually vertical things are things on the outside. So like your k value would be a vertical thing. The a value would be a vertical thing. So when we think vertical, we're thinking outside. And then horizontal is kind of the opposite of all of those things. So horizontal, we know that's left and right. Your horizontal affects your x values. And anything horizontal is, because it's affecting your x values, they're going to be the things on the inside. So like your h, if we have a negative on the inside, things like that. So I'm going to give examples for vertical and horizontal for each of these things, but I'm going to be comparing it to the parent function. So I'm going to draw rough sketches of these. Do the best of your ability on your own paper. Okay, so I'm going to draw two axes. One's going to be vertical and one's going to be horizontal. The first thing I'm going to do in both is draw my parent function. So it's a rough sketch. I just need to know that this is going to start at 0, 0. And kind of go out like that. If you want to go ahead and do that for all of them, because we're going to be doing that for each of these, you can do that. I'm going to go ahead and do that before I do anything else. Right, so these would be our parent functions, and then if we were translating this, a vertical translation would either move this up or it would move it down. So I'm just going to draw what those different things would look like. Your vertical translation would be your plus k at the end, or it could be minus k, whatever that is. It tells you whether it moves it up or down. Your horizontal translation would move it left and right. And that would be your minus h on the inside. And that helps us determine if we're moving it left or right, but it's opposite. If it's minus, you're really moving it right. If it's plus, you're really moving it left. For reflected, that's flipping it over the x-axis, and your A value is negative. And let me do this to show that this is for horizontal, you don't really see that unless it's been moved left or right. So I'm just going to draw this kind of over top of this. And to show that it was flipped over the y-axis, I'm just going to kind of go like this. So it went like this. If there was a horizontal reflection, we have a negative x on the inside. Then we've seen vertical stretched and compressed. We haven't really seen horizontal stretched and compressed. So I'll show you what it looks like, but you're not really going to see that in this class. You'll see that more in algebra 2. So if we have something that's vertically stretched, you know it gets narrower. And your A value is a fraction. So we can say, I'm just going to write this, and then I'll explain what it is. This is 0 less than A less than 1. That means your A value has to be, I'm sorry, that's the wrong one. No, A is greater than 1 is what this should be. I was thinking compressed. If A is greater than 1, then it's some number bigger than 1, and it vertically stretches. So if you were writing a description for this, you can say this is stretching towards your y-axis. I'm going to write that as a small note. So that's why it's getting narrower, because it's stretching towards your y-axis. Your horizontal stretch does a little bit different. Because your horizontal stretch gets wider because it's stretching out towards your y-axis. I said y, I meant x. And then your compression does the opposite of these two things. Vertically compressed gets wider. And this is where you would have that 0 is less than A, which is less than 1, which really just means your A value has to be a fraction. But with this, it's stretching, or not really stretching, it's shrinking away from the y-axis. Which is why it's getting wider. And then your horizontal does the opposite of this one. This one gets narrower because it's shrinking away from the x-axis. And I know we said this when we were talking about vertical and horizontal, but if you need to go back and rewrite this, this would be something outside, something inside, something outside, something inside, outside, inside, outside, inside. Anytime you're referring to anything vertical, outside. Anything horizontal is inside. We'll have time to do one of these examples and then we'll stop for today and do the rest tomorrow.
Thank you.
So with these, you're given words. It tells you different transformations, and we have to take those words and write an equation. So the easiest way to do this is to recognize what's being said, what's being asked. Translated 4 units down. Is that vertical or horizontal? Vertical. So that would be inside or outside?
Outside.
Outside. So you need to think about what type of transformation it is, where it would be. If you want to write vertical too, you can. And then think about what it's saying. So if it's translated 4 units down, how would we write that? -4. Then 2 units to the right, is that horizontal or vertical? Horizontal. So that would be inside or outside? Inside. 2 units to the right, how would we write that? Not plus. Be the opposite. So -2. So now that we know those 2 things, we know we're going to start off with x squared. So f of x equals, anything on the inside is going to be inside parentheses. So x, we have -2. The square would be outside of these parentheses. And then -1. Do we have any questions on how we set that up or found that answer? Bless you. We're going to be working through the other 3 tomorrow, and then you'll also have time